From lecture 13 onwards in module 2, 3 lectures are dedicated to the Karnaugh map simplification method. Okay, this is a method used to solve the Boolean expressions. Already we discussed in the previous lectures different rules and laws connection with Boolean. Okay, by using Boolean laws we can solve the Boolean expression, but now from lecture 13 onwards we will discuss one more method to solve the Boolean expression or for the minimization of Boolean expression. And in the initial lecture, in lecture 13, we will discuss two variable simplification. After that, we will discuss 3 and 4 variable. And first, we will discuss how to map standard SOP expression in Karnaugh map. Okay. After that, we will discuss the POS also. Okay. And different cases also we will discuss in the lecture. In very brief, what I mean by Karnaugh map is actually used to simplify the Boolean expression. Okay, when you do the problem, we will discuss different properties of Karnaugh map. And when you use Karnaugh map for the simplification of Boolean expression, we will get a minimized expression. Minimum number of variables will be at the end of the process. Okay, but there is a condition that if we properly used, okay, then only we will get the minimum expression. The answer will not be wrong, but you will not get the most simplified form. In order to get the most simplified form, you need to use all the rules properly in the Karnaugh map. And we will go to the first case, how to handle Karnaugh map for two variable Boolean expression. And this is also for SOP implementation, sum of product implementation. There are actually 4 minterms for a 2 variable. Means if you are using 2 variable, for example, x and y, for example, 0, 0, 0, 1, 1, 0, 1, 1. You can write 4 different combinations. So from the previous lecture, from lecture 12, you know how to write the minterms. Okay. So this is the minterms corresponds to 0, 0 is x bar, y bar, and this is x bar, y, and this is x, y bar, and this is x, y. So this is the minterm corresponds to different values. Okay. And you will get 4 combinations. So if it is a 2 variable, 2 square, you will get 4 different minterms. And each square in this particular table represent each minterm. So if there is a 2 variable, okay, for example, x and y, I can write like this: one variable in row wise, we will write another variable in column wise. Okay. So x can take 2 values, 0 and 1, and y can also take 2 values, 0 and 1. And this 0 is actually represented by x bar, and 1 is represented by x. Here the 0 is represented by y bar, and here the 1 is represented by y. So if you take the first row and first column, this M0 is actually represented x bar, y bar. Or in other words, we can say this is 0, 0. This particular cell represents 0, 0. Or I can say that this is the minterm corresponds to M0. Okay, first thing. So we can write M0 here. Next one, x bar, y. Or you can write 0, 1, which is M1. Okay, minterm M1. We already discussed in lecture 12 how we can write the minterms, and we are using small letters m for representing minterms and capital M for max term. So this is minterm actually, and here it is x, y bar. So 1, 0, that is minterm 2, M2, and the last cell is actually x, y, which is represented by M3 or 1, 1. Okay, so we got the idea how we can represent each cell in this particular table. The same representation you can see here. Okay, the final form. Now we will move to the problem. Okay, we need to simplify this particular expression where f is given by x bar y plus x y bar plus xy. Okay, so in order to solve this, we need a k map. Okay, So I can draw a K map here for two variable. So this is X and here it is Y. So we need four cells, two rows and columns. I can represent 0 and 1. Here also 0 and 1. This is X bar, this is X, and this is Y bar, and this is Y. Okay. The first term in this particular expression is X bar Y. Okay. This is actually X bar Y plus X Y bar plus XY. Okay. And X bar Y means X bar Y is actually represented by, or in other words, in terms of min terms, I can write M0, M1, M2, M3. So from this expression X bar Y. So this is X bar actually. I'll use another notation. So here it is X bar row and Y means, so it indicates actually M1. So this M1 is in this expression. So I'll put a 1 here. And next one X Y bar. So X second row, Y bar means first row. So I will put a 1 here. And next one XY. So X is here and Y the second column. Okay. Again I will put a 1 here. And only three terms. So I already marked the 3 ones here. And the other cells I will mark it as 0. Okay. Now I need to group the number of ones. That's a procedure in K map. So I will try for a 4 group. If 4 ones group is possible, we'll consider that. If that not possible, we'll consider a group of 2. If that is also not possible, we'll consider a single one. Okay. And column wise, you can group. Okay. In this way, you can group, or in a row wise also you can group. So in this particular example, I'll show you how to group this particular ones. So if you look at this row, there are 2 ones. I can make a group of 2 ones. Okay. And if you consider this particular group, here in row wise, this X is common for both the cells. So I can put X here. And column wise, if you look at in column 1 and 2, there is no common term. One is 0, another one is 1, or Y bar and Y. So there is no common term. So I'll simply put X here. And now we need to consider there is one more one. So you can group this one M1 and M3. So we'll get a group of 2. Okay. And now I need to write the min term corresponds to this particular group. So in row wise, if you consider one is X bar and X, so common, there is no common term for this particular group. But if you consider the column wise, there is a common term, that is Y. So you got one representation for this group. Let me group 1, and the group 2 you will get another representation, that is Y. So we can write your result like this in SOP form: X plus Y. Okay. So this is the final representation of this particular expression. This is we can also achieve by using the Boolean expression. I'll show you how we can write the Boolean expression for Boolean law to simplify this particular term. So if you write this expression, if you consider the last 2 terms, you can take X as a factor, the remaining Y bar into Y. So if you take X bar Y, then Y into Y bar is equal to 1. So you can put 1 here. So if you perform or AND operation with 1, you will get X. So now we can apply redundant literal rule. If there is a term A plus A bar B, and you can write A plus B. So by applying this particular theorem here, you can write it becomes X plus Y. See, by using Boolean laws, you can simplify the expression. The same expression you will get by using K map also. Okay. Now I will conclude this particular problem. So already I mentioned that X bar Y, X Y bar, X Y can be marked inside the K map. The same expression I can represent also in terms of min terms. So this is actually min term 1. Actually X bar representing 0, Y 1, then 1 0, 1 1. So 0 1 is actually M1, 1 0 M2, this M3. Okay, in this way also I can mark the K map. and so M0, M1, M2, M3. If you know the min terms, directly you can mark 1, 2, 3 as 1. Okay. Or I can represent the SOP expression like this. That is, the letter sigma is actually used to represent the SOP expression. Or in some textbook, we'll use sigma and small m to indicate the sum of product terms or to indicate the min terms. Okay. So min term representation. Either we can write f of xy is equal to sigma 1, 2, 3. It's actually indicating that functions having value 1 when the variable is 1, 2, 3. Okay. By using Boolean row also I can solve this. You will get exactly the same result. Okay. This is about problem 1. Now we will discuss problem 2. So in this particular case, again, it is given 2 variable. So we need a 4 variable k-map. We can use a 4 variable k-map here. I can mark x and y are the 2 variable. Here it is 0, here it is 1. And for y it is 0 and 1. Here it is x bar, this is x, and this is y bar, and this is y. Okay. In terms of min terms, if you write, you can write m0, m1, this is m2, and this is m3. And in the question it is given sigma, that is actually SOP form representation, or I can conclude that is the min terms. Okay. For this particular values, the function will produce the logic 1 output. So SOP expression 0. So here I can put a 1, and here also I can put a 1. Now we need to group this 1. The other terms I can represent, other cells I can represent as 0. For min term M2 and M3, the function will give you 0. And if there is a possibility of 4, you need to group as a 4, otherwise 2 or 1. So here you can see that 2 ones, so I can make a group like this. So if you consider this particular expression, in row wise, this x bar is common. Okay, so here it is 0, and 0 correspond to x bar. So I can in column wise there is no common term, so I can simply write this is x bar. So this is the final results corresponds to this particular question. Okay. Now we'll consider another question. Again, 2 variable representation x and y. So I can write x here, y here. So 0, 1, x can take 2 values, y can take 0 and 1. So it becomes x bar and x. Here it is y bar and y. And this is again sigma, that is actually indicating min term. Okay, or SOP in another way. So the first cell is M0, M1, M2, and finally M3. So we need to indicate 0 and 3. Okay, when the min term 1 occur, the function will produce an output 1, another case 1. So the other 2 cells I will indicate as 0. So in this particular example, there is no option to group the 2 ones. Okay, so I need to write there is no option to group as 4 or 2, but there is only option to single group. So I'll consider this one. Okay, and in order to indicate this one, I can write in row wise x bar is there, in column wise it's y bar. So this one is actually represented by x bar, y bar. And if you write this particular term, okay, this one, x is one term and column wise y. So you need to write x y plus x bar y bar. Okay, this is the final expression for this particular k-map. And if you simplify this, you can write this is actually the representation of x NOR gate. Okay, or x or y the whole complement. So this is actually x NOR representation, or we can write x or the whole bar. Okay. Now we'll discuss another question. This is 1, 2 actually, x, y. So 0, 1, this is x bar, this is x, and here it is 0, 1, y bar, and y. And if you write this, this is min term 0, this is min term 1, min term 2, min term 3. Okay. And we need to indicate 1 and 2. The other cells I will put it as 0. Now I need to group this, so there is no option to group as a 4, 2, there is only a single 1. So I will mark it as 1. And for this one, row wise, if you know, look at its x, and column wise it's y bar. Now this is another group. To indicate this, I can put x bar in row wise, okay, column wise it's y. So finally you can write the result x y bar plus x bar y. Okay, this is a expression. For this particular expression, we know that this is an XOR gate, so we can write XOR y. Okay, this is actually XOR operation. Now we need to implement this particular SOP expression, sigma 0, 1, 2, 3. So here you can put x, here it is y, here it is 0, here it is 1. It becomes x bar x, here it is y bar y, that is 0 and 1. And this is min term 0, this is min term 1, this is min term 2, this is min term 3. So in this particular question, it is indicated that its function having value 1 when 0, 1, 2, 3. Means all the combination. Here 1. Okay. So we'll get 4 ones, and by using K-map rule, it's 4, 2, 1. Okay. So if you can make a group of 4, you need to consider that. So I can consider as a group of 4 here. So if you consider this, all the cells are included. So I can simply put the function magnitude is 1. Okay, whatever the values of x and y, your output will be 1 always. Means if you write this x, y as the input combination and the function output f, if it is 0, 0, output is 1. If it is 0, 1, output is 1. If it is 1, 0, output is 1. If it is 1, 1, output is 1. So irrespective of the input, the output is always 1. Okay, so I can indicate the output is equal to 1 in this particular problem. Okay, thank you.